some simple line. And this another thing, it is also like the carboxylic acid group is also represented by this simple line. So you can consider both the things, both the groups are on the same line. But if you see this type of different representation, like here some kind of this wedged bond has been mentioned, and then some of these kind of hash bond you can consider. So these kind of representation is talking about where is the plane actually lying. So before I go into the detail of this, first I would like to explain this. Like whenever you want to do this tetrahedral chirality, you want to represent. So if you want to do this on a two-dimensional surface, so you need to use some nomenclature which are often used to represent the perspective drawings. So what is the meaning of this? I said when you are representing anything by a simple straight line, means you are actually saying like both the things are on the same plane, like AC are on the same plane. But when you are using these spatial bonds like the wedge bonds or hashed bonds, so then you can consider whether that particular functional group it is in the front of the plane or it is in the back of the plane. So when you are using this wedged bond, if it is represented by this, so you can consider this is in front of the plane formed by this ACA. The B lies in front of this particular plane, whereas when you are representing something by this hash bond, so this is going at the back of the plane. Okay, so we can consider how this group is arranged. So B, then A, and then D in some particular three-dimensional way. You have to visualize the structure. So this I will try to be more clear. Okay. So you have understood what is the meaning of this wedge bond and hash bond. So you can consider CH3 is on the back of the plane and fluoro group it is at the front. Okay. So when you want to represent this in terms of some smile string, so first you have to mention what is the center, what is the chiral center. So chiral center here is your carbon atom, and you have to look from any particular group, or I would say any particular atom of a particular group. So here we are skipping the hydrogen atoms in the smile representation. So basically we will say that we are looking onto this carbon atom from the nitrogen. Okay, so if you see the details I have mentioned here on the slide, that you always have some chiral center and you are looking from a from atom. So here your chiral center is carbon, this, and you are looking from the nitrogen. So this is the nitrogen you are writing first, then in the square bracket you are writing carbon, and then you have to denote whether the other groups, other three groups, whether you are looking it clockwise or anti-clockwise. So when you are using add symbol, only add symbol, so I said it is like you can say it is anti-clockwise you are representing, whereas when both of them like you are using at symbol in continuation, means you are representing the structure clockwise. So for example here from nitrogen you are looking towards carbon. Now see, this nitrogen is your actually the I, and you are looking straight in the straight direction the carbon. So how the three groups are arranged? So these three groups are arranged in this particular way. There is the fluoro group, then there is this methyl group, and this is the carboxylic acid group. So these three groups are arranged like you are looking from your eye towards the center. This is your carbon atom, and the nitrogen is towards your eye. So you can consider that when you are looking for this structure, so now you want to represent the other functional groups whether they are in the clockwise direction or anti-clockwise direction. So let me say that I'm using the add symbol, so I should say that these things are arranged anti-clockwise. Only one add symbol I have used. So this is represent. So first you have to represent, you can start from any atom, but now here I have considered carbon. So then carbon, the next atom that what is coming, that is important. It should not be the carboxylic acid group because you have said anti-clockwise. So next atom in the anti-clockwise direction, it should be fluorine, and then it should be carboxylic acid group. Now, for some people, it might be coming in the mind how we have decided this particular way. So this is based on this front and back side. You have to have the three-dimensional visualization. You have to imagine that the CH3 is on the back, then fluorine is coming at the top, and then this is coming on the other side. So this little bit visualization you have to predict. I would say like practice this a little bit so you will be clear about it. So same thing if you want to do this in the opposite way. Suppose if I am, let me erase this. Okay, suppose now I want to use the clockwise direction representation. So from fluorine I am going to start, and this is how it should go. So from nitrogen you are looking at the carbon center, and this is your chiral center, so you have to mention the clockwise. This is 2 times at, means clockwise you are representing. So then you are first writing suppose fluorine, so then the next item should be carbon, it should not be carboxylic acid group, and after the carbon it should be carboxylic acid group. So you can start it from the carbon, but then your direction should be carbon, this C methyl group, this C, then carboxylic acid group, and then fluorine should come in the round if you want to count in that particular way. Okay, so I hope you understood this. For practice, you can just go through this, and there are so many different way of representation is given. At least this particular thing you can practice here. Actually, these things are not represented properly, but this particular thing you can try and practice, so you will come to know how exactly the direction have been assumed. Okay. So this add symbol, this tetrahedral chiral, it is the one of the special cases. There are so many other cases that we are not going to discuss here. But you can consider this how the smiles representation in the simplest form. Even the complicated structures can be represented in the single line notation. Now there are some other rules, like for example, for benzene, if you want to, you normally represent benzene like small c, 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 and c1. But there are so many different ways the same structure can be represented. Like you can consider this is like a alternating single and double bond if you want to represent in some calculate form. So this can be represented in the form of aliphatic carbons. So capital C, then double bond you have to mention, and similarly this alternating thing, so this is also representing nothing but the benzene. Okay, in the same way I said, when you are not mentioning anything means it is having some single bond between them, or you can mention it by dot, and double bond is explicitly you have to mention. But in the same way if you have a these two dots between the carbon atoms, that also means there is a aromatic bond, so you can consider this is also representing the benzene structure. So if you don't want to use this representation, always you have the choice. You can mention all the atom names by the small names. Okay, small carbon, small nitrogen in this particular way. So if you want to represent this structure, so same thing can be represented like this, or you can like here the oxygen is in the aromatic ring. So this capital oxygen in the aromatic ring can be represented by small oxygen when you are representing in small letters. So same thing has been mentioned here. If there is an unknown atom, if it is represented by some star symbol, that you can always have as the representation. Then as you are representing the structures on the computer, in certain cases for chemical reactions also people use the things by the smiles representation. So just for example, if you are having a chemical reaction like some ethanol, if it is reacting with acetic acid, and some agents are there like this, and some product is forming. So generally all these reactants, agents, and products are separated by this greater than symbol. So you can see there is a greater than symbol at two places. So these are your reactants, and this is your products, and these are your agents. Okay, so you can see here this OCC, uh, OCC means your ethanol. It is mentioned later. I said if you are putting any dot between the two things, means this is disconnection. These are two different molecules. So this is a different molecule. This is a different molecule. So this is your acetic acid here that is mentioned first. Then H plus ion and Cl minus ions are represented for your HCl. For ethanol again OCC has been mentioned, and this particular structure is represented like this. So this is the way of representing chemical reaction. Also, you are not going to deal with this much. You are mainly going to deal with the particular atoms when you are trying to determine their properties. Okay. I will share the new slides. Okay, so this is one question I have written. Just read it. We just have started. Okay, so the question I have asked is, as of today,